Okay, simplify. And again, this comes from that high school test. It says simplify is a product of these factors, and the factors, each factor is 1 minus 1 over k squared, where k starting at the number 2. So you got 2, 3, 4, up to 10. Going to the whiteboard to do it, and hopefully when you start to write things down, you might see something. Right, so I'm going to write the product down. It's a product, and the product starts k equals 2, and it goes up to 10. Right, and each of the factors looks like this over here. Right, so the first thing I would do is, write down what it looks like. It looks like 1 minus 1 over 2 squared, 1 minus 1 over 3 squared, 1 minus 1 over 4 squared. I get the idea. This goes on, but it eventually stops to 1 over 10 squared. All right, now I'm looking at that, and I'm certainly not going to compute each number separately, but I want to see if there's probably a pattern to it. I'm going to say 2 squared, 3 squared, 4 squared, yada, 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 up to 10 squared. Now what goes in the numerator? 2 squared minus 1, 3 squared minus 1, 4 squared minus 1, and then 10 squared minus 1. Now what I know about those numerators is they're factorable. And so for this one over here is 2 minus 1, and it's going to be 2 plus 1 over 2 squared. What's the next one going to be? 3 minus 1, and then 3 plus 1, and that's over 3 squared. What's the next one going to be? 4 minus 1, and then 4 plus 1. It's got a really nice pattern to it at this point. Whoops, sorry about it. It's a product, not an addition. All right, goes up here. This would be 10 minus 1, 10 plus 1 over 10 squared. Well, one thing I noticed about this guy over here is that just kind of looking at it, there's a distinct pattern here, and it's going to be 1, 2, 3, up to 9. I'm going to write this down now. So 1 times 2 times 3, yada, 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 up to 9. All right, let's look at the next one. And what do I see over here? 3, 4, 5, up to 11. Let me write that down. So it's going to be times 3, 4, 5, yada, 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 up to 11. Now, what do I get on the bottom? Well, I get products, and I'm going to write them down in two different groups, by the way. So it's going to be 2 times 3. I'm doing this over here, by the way. Times 4, yada, 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 up to 10. But that occurs twice, so it's going to be 2, 3, 4, up to 10. Now, I'm going to reduce now. And how do I reduce that? I'm going to look at this guy over here first. And then after I look at that, I'll look at the next one. And a lot of things cancel there. All right, what cancels? Well, I'm going to say everything seems like they cancel. All these cancel off. All right, one's really not one's canceling, but it's not there. But you get 2 to 9, so it's going to be 1/10. All right, that's not so bad. The only thing to be left over is 10 there. All right, let's go to the next one, and the next one is this one. And then I'm wondering what cancels there. All right, so looking at it, write this down for you. I'm going to say 3 up to 10 would cancel. 3 up to 10 would cancel. What would be left off with? 11 on top and 2 on the bottom. Boy, this worked out pretty nicely. What do you get? 11 over 20. And we're done. By the way, there's other ways to do this. You might have seen this problem before, and you might have been able to prove this by induction, by the way. All right? And it's not a bad way to go if you want to do it by induction, but I think the problem is pretty simple to do if you see it. If you don't see it, nothing's simple to do. Like if you were multiplying this out or doing something else, it would be kind of tough to do. All right? Thank you.